So here we're going to continue talking about the connecting rod project, and we'll describe to you a little bit about the grading policies and what is expected. As you will see from here, then the connecting rod is a very seems to be a very simple device, but in fact it embodies many of the mechanical engineering configurations that we've learned in the class, or we will be learning in the class. And it is composed of different parts of different components, and it's connecting the piston. As you can see, the piston is right here, and it's connecting this to the crankshaft, and the crankshaft is right there. So the connecting rod that we will be designing is the part that connects the piston to the crankshaft right there. So when you design a connecting rod in practice, it has a pin, and the pin is on the top part. It's connecting to the piston, and then it has a cap, and the cap is separated into two parts, one that goes above the crankshaft and one that goes below, and these two caps are attached by screws. So we will be designing this entire assembly. However, we will simplify the assembly and not focus on the screws or the nuts and the washers, and we will assume that this entire cap is just one ring, basically. So the connecting rod is a beam, if you can see the beam, connecting the pin on the top to the ring that connects to the crankshaft on the bottom. And as you will see that we will try to get step-by-step analysis on the connecting rod as we build the knowledge throughout the class. So we are going to ask you to write a detailed report at the end of the quarter, and the detailed report will give all of the steps that have been taken throughout the 10 weeks in the quarter. And in reaching that final goal, we're going to ask you to write an interim progress report in the 4th week that will be like a step towards finalizing the report. In other words, you're going to have a document that is kind of a living document. You will fill it in first with the portion of the work that you did in the first 4 weeks. Then you will turn it in. It will be graded. You will get some feedback, and then you will use this feedback to improve the writing of the rest of your report. So if you look at the grading policy in here, then you see that it is in part like here. If you look at this page, and this page talks about the grading policy, and it says that by the 4th week you will have a progress report, and this progress report is going to be composed of a few sections, and the sections are shown here. You have an abstract, you get 2%, an introduction, you get 2%, engine assumptions and operating conditions, and that is, you're going to choose an engine of your choice. So you'll do some search on the internet and going to the library, and then finding out the different engines and different configurations for these engines in terms of the horsepower and the torque and the size of the pistons and the connecting rod and the materials, and then you'll report on that here. Then you will do a load analysis, and the load analysis will be based on beam theory, and then you're going to use this load analysis to design, using beam theory, the size of preliminary size of the connecting rod. And once we do that, then you're going to pursue a 2D solid model in COMSOL and learn how to mesh it appropriately. And then we would do some preliminary work on two-dimensional elastic finite element analysis, and that would basically complete the report by the 4th week that will constitute the progress report. Then you'll have the same report. You will have a final version of the same report, and the final version is going to be kind of updating all of the few chapters that you filled already, so they'll make them more accurate, better writing, better reporting, and then from that point on the 4th week, you will continue all the way up to the 10th week to update the report and finalize it. And when it's finalized, it's going to have 70% of the grade for that particular project. As we found out, the project is a percentage of the course. It's a significant percentage. So the progress report is going to be 30%, and then the final is going to be the other 70%. And the 70% is divided into sections, and each section you get a certain number of points, as you can see here, depending on how you're going to fill in the various sections. And the idea now is that we're going to move beyond the 2D elastic finite element analysis to do a load analysis using fatigue, because we're going to spend a lot of time on fatigue theory. And also we will learn how to do fraction mechanics. So we'll apply fraction mechanics to this report. And we will learn how to do some design optimization, either by our hands, or if we get a little bit better at it, we might be able to use the optimization tools in this software COMSOL as well. And then towards the end, we're going to do 3D finite element analysis on the final design that we have optimized, and then we get the report finalized. So in terms of the software that you will use, we have to consider two types of software. One is for analytical work throughout the project, and for that we're going to use MATLAB. So I will upload a MATLAB tutorial. Some of you know MATLAB very well, some are still kind of going through it, but it will be a very good opportunity to learn MATLAB and to utilize it and to use it in your project. And in fact, there will be several parts of the project that have either functions or scripts that are kind of half full, and you will just fill it in, and then through fill it in, you will learn how to do better programming and do the design that requires analytical tools. The other type of software is Finite Element, because we would like to have you get the experience using Finite Elements. And these are three pieces of software. First is SolidWorks, to do a 2D and 3D solid models. If we would like, usually 3D is the best for SolidWorks. And then we have COMSOL. We can import from SolidWorks directly into COMSOL, or you could do also elastic analysis in SolidWorks itself. It doesn't hurt to learn both of them, but we will focus on COMSOL because it gives us opportunities to do better post-processing, and also for you, when you do coupling in multiphysics, using COMSOL would be an advantage. Finally, we will do 3D either in COMSOL or in Abacus or in both. It depends on how deep you want to go into the project and what you want to do with the final product. In other words, the project is not a homework assignment that has one particular answer at the end. It is a living document. It's kind of an emulation of what you're going to learn and what you're going to use in practice. and we will guide you step by step. And the way we'll guide you through it is that we have attachments, and the attachments will be online, and the software will be also available through the CSNet. So you have to have a CSNet account, and the CSNet account, if you don't have it, then you have to create it immediately right now. And once you create it, then you log on the remote CES computer using remote desktop connection on your computer. And once you remotely log on to CSNet, you will be able to run MATLAB, COMSOL, SolidWorks, and Abacus as well. So there's a number of attachments to this report. If some of you has a good reader, PDF file reader, then you can actually double click on this icon here and it will open the attachment. If not, then I'll upload them on the website and you have the attachments one by one. These attachments are basically either partial scripts for your guidance or other parts of the project, data or information that is needed throughout the project. By the way, the CSNet, the remote desktop connection, you have to, from your computer, use the remote desktop connection. And once you connect with your username and the password to the CES Lab, then you basically have the software essentially on your desktop. So it will be as if you're running MATLAB or COMSOL or Abacus from your desktop. So now we have talked about we have covered what we wanted to cover in the project guided report in here. And what I'd like to do is move on to tell you a little bit about how to write your report. And the report that you'll write, you have a template, and the template is going to be online. So I'm going to show you the template and then discuss what will be needed from you to go through this template. The template is going to look like this, and it's a kind of a Word document. And once you finish using the Word document, I'd like you to convert it to a PDF file, and then you submit it online, and it will be the same document that you'll use for the progress report and the final report. So the name that you're going to use, it will be the report. You can either write the name of the file will be progress report and then your last name and then PDF, so I can identify who is writing it and what kind of report, either final or progress. And then this is the title and the title of the course and your name, an instructor, and date. And then you go into the report. Then you will find that you have, if you're familiar with Word, obviously a lot of you are familiar with it. Then you have a header, and the header, if you double click, then you can put your name here and your ID, and then the date, it goes here. And once you do that and you close the header, then it will update all the header goes through the entire file. Then next is going to be some notices here about plagiarism. So we want to make sure that you understand that the work is going to be your own effort, and that you don't have you have not taken data from other people or used their information without appropriate referencing. This gives you an idea about the grading, and we talked about this before. So we will try to follow the grading breakdown, as you can see here. So the report you grade is going to be more objective. If you fill in each item, then you get the full grade, a full mark. You don't have any to worry about any non-objectivity in the grading process. Then if you look at the report, it has now a table of contents, and the table of contents is kind of a template for it. It's a field in Word. If you look at the field meaning that it just kind of creates either a table of content or it creates any other field, then you can, if you right-click on the table of contents, once you fill in the report, and you right-click anywhere on table of content, as you can see, then you can click Update the field, and then it updates the entire table, and then it will update everything, and then the new page numbers will be on the right-hand side, and therefore you would just continue building the report as needed. Then next, you have the abstract, and the abstract is essentially telling the reader the key points about your work, which is giving some brief details of the project, and important thing is the objectives and the conclusions from your work. And you have to give the objectives of the work, and essentially the conclusions have to be a little bit more quantitative, so in terms of what you found yourself from this work. Then you have to put a list of symbols, and the list of symbols here must be the symbols that use in the theory, and also the units will have to be here. Then you have an introduction, so I'm going to let you read the introduction. This all is online. So the introduction is what you describe, the importance of the use of the connecting rod, specific discussions on variations of the designs, materials, similar designs, and so on. So you have to be creative. We'll just give you a few pointers here so that you can be guided in writing the introduction. Then you have a section on load analysis, and that's loads, inertial loads, contact loads, axial, transverse, and this is what you will go through the first couple of weeks in this report or this project. Then the engine assumptions, operating loads. You have chosen an engine, and then it has certain assumptions in the design, the expected torque, the RPM range, the spectrum of RPM, consequences on operating loads. So that will be whatever you choose. Then there's a section on beam theory analysis, and that's based on simple bending type calculations for the stresses, and all of us know beam theory, so we'll apply it here on the initial configuration of the connecting rod. Then you're going to do geometric modeling using COMSOL for 2D. And if you are energetic by the 4th week, maybe you will be able to do a full-fledged 3D geometric model using SolidWorks. And then you do some initial finite element analysis and design optimization, and that will be essentially at the end of the 4th week that you will finish this step. And as you continue now, the lifetime analysis will be based on fatigue, based on reliability of the design, surface cracks, and then if fatigue, you can analyzing using SN methods, as we will learn, or using fracture mechanics. So that will come in, that will be really the kind of the meat of the project, so that you can design an optimal configuration of the connecting rod. And then finally you have discussions and conclusions, and the summary will be given here. Now there's a section called references that I'd like to point out. And the references, it will be better in the beginning if you use, so let me just kind of show you in the references in Word, there is a facility that I found it very, very useful to keep track of the references and allow me to add more as I build the report over the 10 weeks. So I'll just describe that to you in case you don't know it. So if you look here, you see that you take in Word here, you go to this is the home configuration tab. If you go to the layout tab, then it gives you the layout, and then you go to the document element tab, Then the Document Element tab will give you at the end here the citations and the references. So the references, you can choose the style, and they have APA, Chicago, MLA, Turabian style, and you can add more. But let's say we select the Chicago style. Then what you do is you start building your references. So when you build your references, you go to Manage the References. Then it will open a window, and the window here gives you some list. So if you want to have, usually if you're starting fresh, then it doesn't have any references, but you can add more. So if you add plus, then it will open another window, and then you put the author, let's say Nas M. Ghoniem, and then you can put the title, design of a connecting rod, and the journal name, Journal of Applied Physics, and the year 2014, and volume 54. This is some of the basic information, and so on. So you can fill that in, and then once you do it, then it just adds it. You can see here, it is added to the list already. So now you're done. So you can, in the beginning, you can add in all of your references, and then once you're done, you can close this tab here. You're done with it. You added all of your stuff. And then let's say at any point here, acknowledgements, I wanted to insert a reference. So I can just go wherever I want to insert the reference, go again to Manage. And then if I just double click on whatever reference I have, you can see it inserted it as a field. And the field is just shown here as a field, and it will update it immediately. So it will build it up in the document. Now at the end, I wanted to have the references. So what I do after I finish this, I go now to the tab that's called Bibliography, and then I can either click on Bibliography. It will just put down all of the bibliography, or Works Cited is the same thing. So if you double click on Bibliography, then it will actually give you this bibliography. Now it showed Ghoniem like that, and then another one like this in the appropriate format. So with this, I hope that I have given you an idea about how we're going to put together your project report, and we will give you additional instruction in the next lectures in order for us to continue the process of design. So with that, I'm going to